Welcome and hi everyone. Today our group will present to you about application of differentiation. Before we start, I would like to introduce our member groups. First, this is me, Nurul Azira. Second, this is Laila Akira. And the third is Nelia Hanan.
So, what is differentiation? Differentiation is one of the concepts that, apart from the integration, differentiation is basically a method of finding a derivative of a function. Differentiation is one of the processes to find the instantaneous rate of change in function based on the variables. So, the most common example for differentiation is velocity, which is the rate of change of displacement respect to time. Next, if the x is a variable and y is the another variable, then the rate of change of x with respect to y is given by dy dx. This is the general function of derivatives, and it is represented as f prime equal to dy dx, where f of x is equal to any function.
Why we use differentiation? Differentiation is a technique which can be used for analyzing the way in which functions change. In particular, it measures how rapidly a function is changing at any point in engineering applications the function may. For example, represent the magnetic field strength of a motor, the voltage across a capacitor, the temperature of a chemical mix, and it is often important to know how quickly these quantities change. In this section, we explain what is meant by the gradient of a curve and introduce differentiation as a method for finding the gradient at any point.
Let's look at problem statement 1. A farmer has 200 meters of fencing. He wants to enclose a rectangular paddock. Find the maximum possible area he can enclose. So this is a problem solution for the statement 1. First, we draw a sketch for easy to do solution. Second, write down an expression for the area of the paddock. Let the width equal to W and the length equal to X. Write the equation into 2W plus 2X equal to 200, and we simplify it into W equal 200 minus X. The formula for area equal to length times width. We substitute the equation before into this equation, that is A equal to X in bracket 100 minus X. We simplify the equation into the 100x minus x to the power of 2. Step 3, we differentiate A, and we got A prime equal to 100 minus 2x. Next, to find the maximum or the minimum value, we must put A prime equal to 0, like 100 minus 2x equal to 0. We simplify it and we got x equal to 50. Step 5, we must carry out the second derivative test, which is we got A double prime equal to negative 2. This is a negative value, which means it a maximum value. For the last step, substitute into the original equation to solve the problem and write out the answer, which is when x equal to 50, w equal to 150, and we got w equal to 50. So we can get the maximum area with length times width, which is 50 times 50, we got 2,500 meters square. So the final answer of the problem is the maximum area of the paddock is 2,500 meters square.
Next, problem statement 2. For the question 2, a spherical balloon is filled with air at the constant rate of 200 cm, power of 3 as power of negative 1. Calculate the rate at which the radius is increasing when the radius equals to 10 cm. For the problem solution, let V equals to volume and R equals to radius of the balloon. Firstly, V equals to 4 over 3 pi R power of 3. Next, dV over dt equals to 200 centimeter power of 3 as power of negative 1, which is increasing rate. dr over dt equals to dv over dt times dr over dv. Next, dv over dr equals to 4 over 3 pi in bracket 3 pi r over 2 equals to 4 pi r power of 2. Next, dr over dv equals to 1 over in bracket dv over dr equals to 1 over 4 pi r power of 2. When r equals to 10 cm, dr over dt equals to 200 times 1 over 4 pi in bracket 10 power of 2 equals to 1 over 2 pi centimeter as power of negative 1.
So in conclusion, we can know the meaning of derivatives, the use of derivatives, and how to solve the minimum and maximum problem. Lastly, we can conclude that the concept of derivatives is important to calculate our problem in our daily life.
That's all from our group. I hope you can enjoy our group presentation.